Example 4 asks us to determine the number of points of intersection of each of the following graphs. So we start off with looking at A, which is y equals 3x squared plus 4x minus 2. Okay, so what we want here is to find our discriminant. We could graph it, but if we just look at our discriminant, we already know how many it has, because it's only asking for the number of the points, not what they are. So we can go and say, okay, well, what's b squared minus 4ac? So its discriminant is going to be 4 squared minus 4 times a times c. This is 16 minus 12 times negative 2. So it's going to end up actually being a positive 24. So we get 40. This means we have 2 x-intercepts. Right? A positive discriminant means 2 x-intercepts. B says y equals x squared minus 10x plus 25. Okay? So then we do the same thing, right? We're looking for b squared, so which is negative 10 squared, minus 4 times a, so there's 1x squared, and then what's left is 25. So this is 100 minus 100, and that equals 0, right? So at this point our discriminant is 0. It's actually a perfect square, and that means that it's going to have 1 x-intercept. So in the last section we called this 2 real and equal roots, but it's only 1 x-intercept. And then lastly, we're going to look at the last part, which is y equals negative 2x squared plus x minus 7. Okay, so at this point, we're going to do the same thing, right? It just wants to know the number of intercepts. So we do b squared, which is going to be 1 squared, minus 4 times a times c. We get 1 minus this, so 4 times negative 2 makes negative 8. Negative 8 times negative 7 makes a 56. And so this is negative 55 overall. That means we have 0 x-intercepts, right? This graph is never going to touch the x-axis. It only has imaginary solutions to it. So if it so the big key to this question is reading it, and it says determine the number of points of intersection. It doesn't ask what they are, so you don't actually have to go further than this. If you know that the discriminant is going to tell you how many it's going to have, then just use that. It's a simple tool to figure this out.